So how do we graph linear functions? Well, there's three methods, and you've probably seen all of these before, so this is really revision. We can use the gradient intercept form as we just did, and you use that by plotting the y-intercept and then kind of using the gradient to kind of build, I suppose, the rest of the line by making a point either above or below. Or you could do both to make sure you've got 3 points, check they line up, put your ruler on it and rule it up. You could also find the x and y intercept. Now you find the x-intercept by letting y equal 0 and solving for x, and you find the y-intercept by letting x equal 0 and solving for y. That should give you 2 points. You can put your ruler on those 2 points and then draw up your line. Now, the only thing to consider is that that method won't work if your line goes through the origin, because perhaps it only has one intercept altogether. So let's graph this line using all three methods so that you can decide on what's your favourite and make sure that you know how to do all three. Now, first I'm going to graph this using the gradient intercept method, and it's already ready to go. If it was in general form, I could rearrange it to get it in this form, but as it is, I can see that the y-intercept is 2, so you'd find where 2 is. With graph paper, obviously, that would be simple. And then you need to build a gradient of 2/3. Now, it's a positive gradient. That means it's going up this way. As you read the graph from left to right, you're climbing a hill. And I find it handy just to jot down a quick triangle showing that the rise is 2 and the run is 3. That means if we pretend that our point is down here and we want to find this point, we need to go 3 jumps to the right and then 2 jumps up. So you can literally go 1, 2, 3 on your graph paper and then up 2, put a dot. That dot is now on your line. Similarly, you could imagine this is the top of your triangle. Go down 2 and left 3, down 2 and left 3, and you're going to have this point here. Now, it's not a bad idea to do 2 just to double check that they line up. At that point, you'd put your ruler on it and draw your line. Okay, how would we do this if we were finding intercepts? Well, if we're finding intercepts, we would say, all right, let's let y equal 0, and we'll solve it for x. So we rewrite the equation, but don't write y, write 0. So we'd say, okay, 0 equals 2/3 x plus 2. Now we need to solve this. Now, fractions aren't very nice. Let's get rid of fractions by multiplying everything by 3. We'll multiply this by 3. It'll still be 0. Let's multiply 2/3 by 3. It'll just be 2x. And let's multiply this by 3 as well. Now we could subtract 6 from both sides. So -6 is equal to 2x. So then we can see that if we want x, we need to halve both sides, and we can see that x is -3. So drawing that up, we find x equals -3 over here, and we put a dot. Now to find the, I need a better pen. Now to find the other intercept, I can say, let's let x equal 0 and solve for y. So we write it out again, but when we get to the x, don't write it, we write 0. So we've got y equals, now 2/3 of 0 is just 0, plus 2, obviously y equals 2. That one was much easier to find. So now we've got 2 points. That's enough. We can put our ruler on that and draw up a line. Now you'll notice here that with our last method, we built 3 points. That was kind of a good backup plan, so that in case one of them was wrong, we could spot a mistake. With this method, you've only got 2 points. So if one of them's wrong, your whole line is going to be wrong. So a little disclaimer there about that method. And the last method you can use is to draw up a table of values. Now, you can choose any values you like for x. So maybe just choose nice, easy ones. How about 0, 1, and 2? I always like to do, for a straight line, at least 3 points. That way, if I've made a mistake with my calculations, it'll jump out at me that they're not sitting in a straight line. Now, if x is 0, sub it in. 2/3 of nothing is nothing, plus 2 is 2. So that gives me the point 0, 2. So if over here I hadn't graphed anything at all, I could say, right, I've got 0, 2, that's there. And now when x is 1, I've got 2/3 of 1, that's 2/3. 2/3 plus 2, that's 2 and 2/3. So I've got the point 1, 2 and 2/3, and that's going to be there somewhere. And then when x is 2, I've got 4/3 plus 2, and that gives me 3 and 1/3. Okay, so I've got these points here. Now, they're not exact points, so I think you can see here that depending on the equation, the points that you choose will perhaps make your life easier or harder. How about we do another one just to be sure and get a nice even value? If we do 2/3 of 3, that's a nice whole number, 2. And 2 plus 2 is 4. So I think that would be a nicer point there to graph. So we've got the point 3, 4, so we'd go across to what have we got? 1, 2, 3, up here to the point 3, 4. And now we've got a whole bunch of points we can put our ruler on it and draw up our line. Now, a disadvantage here is we can't see what this intercept is, but we could always work that out and say, hey, what about when x is, what about when y is 0? You could figure out those other points. So you've got 3 methods there, and they're all good to have in your toolkit at different times. For this one, I could put it into gradient intercept form if I wanted to use that method, but perhaps for this one I can see that I'm not missing any of the terms, so it's going to be a diagonal line. So one like this, perhaps finding just 2 points, the x and y intercept, might actually be the quickest and easiest method. So if I let x equal 0, then this part will be 0, and I'm just going to have minus 3y plus 4 is equal to 0. Subtracting 4 from both sides, I get this. And then dividing both sides by negative 3, a negative divided by a negative, is going to give me just 4/3. Now if I let y equal 0, then I'll say I've got 5x minus 3 zeros is just 0, so I don't need to write that. And now I've just got plus 4 equals 0. Solving that, let's subtract 4 from both sides. Now let's divide both sides by 5, and now I've got negative 4/5. So when I go to graph that, I can do a graph here without even using graph paper. And because in an exam, mostly I just need to know the mathematical features of the line, I don't necessarily have to have it perfectly to scale. It would be quite acceptable here to say, well, this is 1 1/3, y equals 1 1/3, so let's make that up here. And this point is x equals negative 4/5, that's a little less than negative 1, we can just sort of put that here. Now I've got my 2 points, I can join them with a line. Obviously using a ruler would be a nice idea. And that's a perfectly good way to graph this line, 5x minus 3y plus 4 equals 0. And I think you can see that that can be a little bit quicker sometimes than drawing up a table of values or rearranging it into gradient intercept form. But it's important, of course, to remember that if you're using this method of finding the x and the y intercept, you need 2 of them for it to work. So if you've got a horizontal line or a vertical line or a line that goes through the origin, there's only going to be 1 intercept. So this method would completely fall down. And that's why you need a backup plan, table of values or gradient intercept form. Now you should be able to see that both of these functions are the exact same straight line. This one is in, I guess, general form, although it hasn't got any constants, but it's got some x's and they're positive, and it's got everything on one side and it's equaling to 0, and there are some y's in it. But if I just add y to each side, then I'll have y equals 3x. So you can write it either way around. Now, you wouldn't necessarily want to graph this by looking for intercepts. I can tell that because it has no constants, it's going to go through the origin. And you can see that because simply subbing in when x equals 0, what's y, you can see that when x is 0, y is 0. So if it's going through the origin, and it is a straight line, it can't be going through any other point on either of the axes. So what do we do? Well, it makes sense to say this is actually in gradient intercept form. It's just that the intercept is a great big 0, okay? And that's telling you, hey, the y-intercept is actually at 0. So you can read straight off here and say it's got a gradient of 3. What does that look like? Well, it's positive 3, so it goes up this way, and it means that it's got a rise of 3 for a run of 1, so it's quite steep. So literally drawing it in like this as quite a steep line, and then putting a point on it to give it some sense of scale is all you really need to do. So if you'd said, say, x is 1, what's y? Well, when x is 1, y is 3, you can plot another point there just to give your graph a little bit of form, and that's all you need to do.